this video is specifically for you with the question about the field piece and hooking up your micron meter. I don't have a field piece micron meter because I use the AquaTools BlueVac, but this should hook up exactly. We're going to pretend this is your field piece micron meter. And as you can see, it's already in microns. I stored it here since last night. It's just been holding microns like that. But we're going to bleed that out to atmosphere. So let's open this up. And let's get this back to 0 atmospheric pressure. Let's bleed it open. And we're using this line. And we're going to lunch right now, but I'm doing this just before I take off to that. So let's open up that. Okay, now we're zeroed out. We're at sea level pressure right now. We're in San Francisco. So in my location here, I'm probably about 25 feet above sea level. And so you have your micron gauge, it's turned on, the Bluetooth is on, and it's sending out a signal with the Bluetooth. You have your iPad on, you have your Bluetooth on, you already have the field piece software. So let's go into measurements. And if you scroll down, we have to, okay, so we're connected already. You see where it says 0 PSI? But if you tried to use this for microns, it will not work because this only goes down to 29.9 and that's it. You have to go over to, you see where this temperature gauge is? That's your temperature and pressures. That is reading temperatures and pressures right now. So we're gonna go over to this one. You see that little square with the arrow in it? That's gonna be your micron. So it says link tool, see evacuation. Here's tightness test for nitrogen. We're not doing that. Evacuation, link tool. You have to make sure your Bluetooth is on. Link tool. And it says the S-man, but in your case, it's going to show a picture of the little field piece micron meter. So you click on your micron meter. Now it's activated, but you'll read nothing because it's at atmosphere. So it's 0, 0. Hit that button and hold that button. Okay, listen. It's kicking on. And I think, oh, let me kill the vacuum tank. Okay, we're going down. And let me see if we'll keep that there too. There it goes. We got into microns. Now and I hit that. Did you see what I hit? I want to scale it down. You see it's already into 1300 microns. Now let's data graph it. Now let's come over here because we don't care about this. Your gauge will be reading this. But if you wanted to use the software, you see where we are right there? We're down at 1200 microns. See if I could get some of that glare out of your eyes. And we're going down a little more. And we're going down a little more. So you're now grafting out over time the micron reading. You can see it following here. And that's how simple it should be. I always notice many things work better with iPads, and that's why I got an iPad. I used to have Androids, but I was forced to go because there's a lot of things. At one time, it used to work better with Android, but a lot of the companies have switched working better with software, with Apple products on some things. And some things are not available at Apple at all, and you have to use Android products. I switched over to this because it was just easier and more reliable. All right, and if you have an Android pad and you want to get an Apple, you don't have to get the newest one. This is simple, low resolution, low speed, low processing power. You can buy the cheapest iPad and you can even get a used one. It does not have to be high end at all. All you're doing is simple little data points. That's it. Nothing rocket science. So don't be worried about that. Oh, I got to go spend $1,000 on an iPad. No, you can get the cheapest iPad for $400 or get a used one for $250 or something like that and experiment. And that's it. And we're going off this little guy right here. And I think I know why these guys die and they kill themselves. The electronics overheat. And, you know, because I'm turning it under warranty, I'm not allowed to open these up and crack them open and go to the circuit board. But this gets so hot after running an hour, and that's not even in hot weather. I believe I'm going to have the same failure again, and it's going to be on the circuit board, on the drive board for the inverter inside here, because their components are not rated for the heat they're producing on their circuit board, and there's not enough cooling fins here, and there's not enough airflow to save the circuitry in there for a lot of use. All right, I'll see you guys later. And you touch that, 901 microns. You can touch the screen and it'll tell you other than just reading down here. And see you guys later.